session. It's not going to be super short as well. We'll cover a few items here. Let's make sure we're recording here. Okay. All right, welcome back, everybody. We're running a smaller class today, and I have to say, maybe it's my bad. I set up the meeting very late this morning, actually, so it might give folks some impression that we don't have a class today. But anyway, so let's get started. I'm experimenting something new here, not entirely new, but some new about the slides. So when I was writing on my pads in PowerPoint, it always gave me the jittering errors. I have to always fix those. I found something that's supposed to work better. I tested it; it does work better, but it's another software piece. It requires, a different routine. Hopefully, I won't break it. We'll have to see. So let me switch over to some slides here. Okay. Here, to get the chat. And once, okay. Give me a hand if you can see the slides on a slideshow window. I haven't put on the presentation yet. Great, thank you. I see the hands, many hands. Thank you. Now, next step, slideshow. I will need to exit full screen, but hopefully you can still see the slides. Black background. Is that still true? Yeah, great. Thank you, Stacy, and many others. Great. Okay, so this is Google Slides, and when I have to annotate, I will use this annotate add-on. And while I'm presenting, I'll turn on this fancy tail here. Laser tail. And that's it. Okay. So you can see it clearly, not only being able to see the slides, but also can see it clearly, right? Let me flip through few slides. All right, assuming you can see clearly, great. Windows. A little bit. Okay, great. Now it's week 9. How time fast. Time flies fast. Last week was the spring break. The previous week was the first exam, and so we'll first touch on the exam, review the results, and see if you have any remaining questions. I'll go through a few questions that are on the tough side based on the outcomes. And then we'll talk a little bit about the teams for the remaining activities for the course. Preview a little bit about Module 6. You have been learning Module 6 before the spring break and continuing to do that. And start to learn Module 7 this week. I will highlight a few things that are the most important, I would say, to pay attention to when you go through the materials for these 2 modules. And we'll touch on homework 4, which is due coming up next week. And then Q&A to close today's session. So it's not going, none of these is going to take a long time. to go through. So, and with hopefully everybody in a good mood, I think, or almost everybody in a good mood, we can go through them fairly fast, I think, given that you're in a very good position in the course so far. I'm really glad. So here it is. This is the first exam result distribution. The total number of points is supposed to be 15, right? But there are some bonus points, so it's possible to go over 100% of the 15 points. So that's why a lot of you scored more than 100%. Very good job. I'm very glad. I'm very pleased to do the grading, and the grading process was very pleasant. Thank you for that, and thank you for learning the materials and following the course materials, and then following the tips that I probably mentioned throughout the course. So here is to you, actually, average percentage point, 98% of the class. This is very remarkable, I would say. 29 out of 37, that's close to maybe 70% or more. Got 90% or above. 33 of the 37, that's more than 90%. Got over 80% of the points. 80% of the 15 points. I would say, if you falling to take a look at the grades and feedback on Blackboard, if you fall into the red and yellow zones, please reach out to me, reach out to your TA, reach out to a lot of us. I would say a lot of us that are attending. And if you're not here right now, when you watch the video, you know that many of us are happy to help in any way possible. Even if you don't have much time, I know that one factor that is that makes it very challenging for a few of you is the time. You don't have the time because you're working, or you're part-time working, or you have internship or other commitments. Even so, I think many of us can teach you a few quick tips that will save you a lot of time exploring or trying to figure out what best way to do something. So those tips go a long way. Don't be shy to ask us. We're willing to help you. That said, majority of this class, especially majority of you attending today, congratulations. I'm very happy for you. Now we are going to go through a few of those tough questions. Maybe you still have questions, even if you're here, you probably missed one or two of those questions. Any questions before I move on?
No, Professor.
Yeah. No? Okay, great. Now let's dive into some of the specific questions so we have 37 students in the class. The questions that lead to some of the losses in the points, even if it's a partial loss, are question 11 and 12. Then that's it. All the other questions, majority of you did very well. So we'll go through question 11 and 12. Even if you have done it, I'll show you a few other ways to kind of, as an explorative learning process to widen your tool set. In terms of the bonus questions, slightly more, than 11 or 12, could not find a way to do it. And I'm here to show you to unpack the questions. So that is it for now. And that is related to one of the bonus questions. So I'm going to switch over to Jupyter Notebooks. I'll leave the slideshow, but go over to the Jupyter Notebooks. Let's see. Make it bigger. Oh, is it big enough? Can you read? Can you read the letters here and the codes when I write them? I couldn't. Let's see. Can you give me some response? Can you read the questions and the texts in the Jupyter Notebook clearly?
Yes. Yes.
Okay, great. Thank you. All right, so question 11. By the way, I didn't plan to talk about any other of the questions because I thought, that might be a waste of time. What I have to say is probably what you have already known and already used. But if you would like me to go through any extra questions, just let me know. Maybe after we have talked about question 11, 12, 14, and 18. Okay. Question 11. Yeah. So question 11 gives you a list. First, last one. Give you a list of names and a list of numbers that are in string formats. And then question asks you to make a series. You know what series by now, but you know what series is by now, right? And to make a series, according to the desired outputs, and this is the desired output. It may at first look confusing because there are two columns. It looks like it's two columns, so it looks like it's a data frame, but given that it's a series, these must be the index and the notes, notes about that. The problem is almost everybody who did the study, right, knows to get to this point at least, to make a series. I simply didn't assign it to the name, but you know the drill. So everybody is able to get this, right? So you would at least get some points, but maybe not all of them. If you observe the outcome with the desired output, the index needs a bit more work. The index does not only look like numbers, but it has some prefix to it. And you observe that the prefix is the same before each of the number. And the prefix is NO number, short for number done, NO done, and there's a space. And the space here is not particularly an issue here. Now, those who figure out how to do it didn't miss the space at all. So the thing is, how do you add that prefix into the index? Each of the index values, not index, the index label of the series. So that's really what is, the added challenge here. So I'm going to talk about 3 ways, and let's see, which way did you use? The first way is perhaps that most students who made it adopted the approach, and the approach is list comprehension, because the module talks about it, I think, even though it doesn't make a big deal out of it, but the once you know how to use it, it's super useful, super effective, and it's satisfying to use it. You know, it's basically a for loop condensed into one line. So that makes it very satisfying to code from purely coding perspective. Okay, so how do you do that? To use list comprehension, list comprehension is used for something that you can achieve by using a for loop. Imagine that you can go through using a for loop, go through all the values of the index, the list that's supposed to be used for the index values, index labels, and in every iteration, you can add that prefix into the value and make it some number followed by a number. That is a classic for loop maneuver. And then list comprehension can achieve that. So here, if if list comprehension can be used to achieve this task, then a for loop can also be used. And I guess the sad thing is that there's a requirement here. You cannot exceed 3 lines. If you use a for loop, you most likely will have to go over 3 lines. So, that kind of rules out the for loop solution. But even if you used for loop, even if you exceeded 3 lines, you're most likely going to get most of the points because, being able to do it is more important than anything else, other than hard coding. And for loop is not hard coding. So using list comprehension, you are going to unpack. So it's like for loop. So you will begin. I always begin with a for loop format for each of the item in the index 11 for each of them, and then at this point I can use the list comprehension, the list the list grammar here. So for each of these, do what? Put the task in ahead of it. Do prefix something, number, prefix that to each. So if I do this, I'm going to get a list, a slightly modified list of the given list, and then such is the values for the indexes that I need. And then I confirm I can do that. I put it in my index 11. Okay. And then I simply have to modify this, and then I can get that. Right, so that's the first method. This is the method that most used, if you were able to get here. The second method is to use a smart, but although not many would know at this point, a smart method of the pandas data object, data frame, or series. Both of them have that. And I can do it. So let me demonstrate first. To do that, I need to have the series first. So I define the series first and then use the method of the series. So I'm going to give it to the question asked me, my as I can't believe I just said that. Obviously, this doesn't sound very good. So I'm going to say my series 11, okay, instead of saying my 11. So my series 11, but I have to reverse the original index value. So this my series 11 is going to look simpler. It's not the ultimate the ultimate, I guess, the ultimate outcome. So the first step is to get the series, and then let's check. It's simpler. It's not the ideal, right? And then, so then once you have the series, you're going to use to call the a method called add prefix. So let's take a look at what it does. Let's go to Google. Here, pandas series. Let's do. It works out the same. Well, it works out differently from with the data frame. So why don't I go to the data frame and I'll see both use cases. So working with data frame, you have and series, you have a long list of different methods that helps you achieve things that is a little bit more cumbersome if you want to, do it from the ground up. So they have thought about typical scenarios, use cases, useful ones, and then they program out for you so that you can save a few lines. Prefix, add prefix is one of them, and you immediately see add suffix there. So it's a simple, extrapolation. You can think of that. Make it bigger. So what does it do? Data frame dot add prefix and give it the prefix. Typically it's in strings. It's a scalar string. Prefix the labels. So what does it mean by labels? For series, the labels are the row labels, the indexes. Series only has one index object. For data frame, it only prefixes whatever you provide as a prefix on the column labels. For data frames, the row indexes typically are not as critical, although it is critical to make sure data integrity purposes. But the column labels are more useful for managing the data set, cleaning and organizing and manipulating data set. So we typically do things on columns, so the columns, the names of the columns are more meaningful. When you slice a column, you can use the header, the column label. So prefix for the column labels are more useful. So understand the differences here. And we are calling it on series. So we're changing, we're prefixing things on the indexes of the series. So my series 11. Sorry. I'm calling my series 11. I'm prefixing something. I'm prefixing the string before each value of the index labels. And after that, the job is not done. Be careful. Even if you clearly see the result, it hasn't been recorded in my series 11. So you will have to assign it back, my series 11, and then you check the result. You get it. So this is the add prefix method of the data frame or series data objects. And only one student were able to do that. Kudos to the student. 3. The third method is kind of like it's a long shot, but it's still a shot, right? So what happens is that let's say, it's very much like what do we call it? It's very much like broadcasting. So say I'm simply, if I have something like an array. I have an array of strings, and I simply need to add something in front of everything. And think of it like a math. In math questions, if I have an array of numbers, I want to add something onto it, the same number onto it. I simply add the scalar to an array. It gets applied to every. So a for loop is programmed in NumPy array. And I would like to leverage that feature. So broadcasting, kind of. I'm trying to leverage the broadcasting function of arrays. But you might run into problems, and let's see. So index 11 is a list. Obviously, a list. You cannot add something to every member of the list, and hopefully it will, and hope that it will broadcast. No, broadcast only happens on arrays or any any other more advanced data objects that has more functions built in. So you have to make it a NumPy array first. And then I got an array. And once I have an array, and let's try if I can broadcast the plus function. If I plus two strings, it's going to glue them together. It's concatenation. So can I use concatenation or the plus function of strings on broadcasting? So if I try number space plus that to the array, does it happen? It says add function, the universal function add did not contain a loop. So it doesn't enable, for strings, it doesn't enable a for loop of broadcasting to every member of the array. So what can I do? Let's level the game up. If NumPy array couldn't do it, let's try series. So let's remove this and take a look. If I do this, it's a series. These are what I really am trying to use. These are indexes created automatically by series. I don't care too much about them, but they have to tag along. That's fine. And I try to use the broadcasting on series. Let's see what happens. It made it. It does the job. It doesn't change the indexes, but it changes the values. It adds, it broadcasts the concatenation, string concatenation on every value of the series. It'll also work on data frames for sure, but since we only have a list here. Okay, so now then what do you do? If let's say I'm still trying to modify the index here, so don't get carried away. Don't lose your focus. We're still modifying the index, and in order to modify the index, in order to use the broadcasting, I have to use a series. It's kind of funny. That's why it's a long shot. It goes all the way to series and come back to modify the index. But this is my index for 11. So I get a series, not an index. But in order to get the values of this series as the index, I will need to get the values. So this is the values that we talked about. Or for a series, you can also use toList. The values will get you as an array. toList will get you as a list. Let's take a look. I get a list. And then I use that, my IDX, to define my series 11. Run that and then check the result. I get the same. So, the conclusion, there are 3 ways to do that. The first and second way are effective, smart, or standard ways that you can do that. The third way is a long shot, but it's fun. It's fun to know, at least. In other use case scenarios, you might be able to leverage broadcasting over string values by leveraging series and data frame. So clearly a for loop functionality is built into series in the case of strings, better than the NumPy arrays. But for numbers, I believe they are quite similar. All right, so that's question 11. That's all. Now question 12. Let's run this. Question 12 gives you a string. It's one string, 26 English letters, and then a list with 3 labels supposed to be used as the column label. So the question asks you to make a data frame with the values being a sequence of even numbers beginning with 0, and it tells you the last element is 46. So it's straightforward to think about the range function, right? To define a sequence, and then but that's not all. If you use the range instead of a range, if you use range function, you get a sequence, but you will still have to put it into 8x3 matrix shape, and with range it's harder to do that. So better use a range. The two a range is created with range in mind, but also with NumPy array functionality in mind. So it's a super range, if you will. So a range is clearly preferable here. Using a range, you get an array, and it's easy to reshape into the correct shape. Most of you, if you attempted this part of the question, most of you are able to get here. So, and simply use the columns as is and skipping the cumbersome index values, most of you can get here. It's already half of or more than half of the points here if you get here. The values are correct, the column labels are correct, the shape, dimension is right. The only thing that's missing is the index value. So let's take a look. For the index values, there are 8 of them. You need to get these letters from the string, not only simply by typing C, what's the next one? C, F, maybe, and then so on and so on, C, F, I. Not hard coding them by simply typing them as a list, but using slicing to slice these following a pattern. The pattern is specified here. So to do this, it's a journey that kind of goes through several steps. But there's mostly only one way or one logic to maybe several ways to implement it, but they are not very different. So it's basically using some kind of slicing maneuver. First of all, I want to get the index positions of the sequence of letters C, F, I, and the pattern has been revealed to me. Beginning with C, C is the second position. So if I use range to construct the sequence, it starts with index position 2, I get C, and then every third, the gap is 3, and then the last one, I'm just going to say 26 because 26 is the 1 plus the last index, and since the last item is X, it's most likely running to the very end of it. So I get this sequence. I will attempt to use this sequence to slice the 26 English letters. So that's my immediate thoughts. That won't work, as you know, but it will get me closer. So with string 12, I'm trying to slice it. I get an error. String indices. I'm trying to slice a string. String indices must be integers. This is not an integer. Even if I convert these to list, still not going to work very well because it's a list of integers, but it's not integers. So at this point, hopefully you realize that we talked about slicing. Slicing object is not is different from range, but works very similarly to range. So at this point, you would prefer to use the slicing object here, right? So that will get you all those English letters. But if you try to put it into define the index of the data frame, it won't work. It will give you an error because if you observe closely, the index is only one string, but you need 8 of them. You need to convert it to a list. So at this point, you have 2 ways to do that. You convert the whole thing to a list. You get a list of letters, or you convert the English letters as a list and then slice it. You know, the 2 ways get you to the same point. So now you replace the part that has issues, and then you complete. I think, did I miss everything? Complete one more square box and necessary. Okay, at this point, you are able to complete the problem. Yeah. To make it complete, my data frame 12, define it, arrange the lines, and then check the output. That's correct. Okay. Any questions at this point? Let me check mine. No chance there. So, you know, although it looks simple to get from the string of letters to a list of select letters, it actually go through several steps. It's okay to make mistakes in the middle, but it's very important to be persistent and to deal with the feedback, analyze the feedback when you get an error, and then work through it. Most of the coding challenges are like that. All right, so that's the 2 regular questions, 11 and 12. And now let's talk a little bit about the bonus questions. So number 14 uses the same matrices, or the same 3 data objects from question 13. They are the same, and they look big. The task here is to append them, you know, row after row instead of merging column after column. Sidewise, this is vertical. Conduct an appending maneuver with the inner join type, the intersecting append. So some of you attempted to use the data frame.append, such as BF14, the append, you know, you can append, it's like concatenate, but it's vertically concatenate.
somebody used append, but in the end you found that you have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and then you have 7 columns. But the question will only the question asks for output that is only just 1 column after being squeezed. It's a 1 column. So because the question asks for the inner type of append, not the outer type. And if you go to data frame and look for append and look at the information here, you'll find that it's going to be deprecated, or it has been deprecated. Interesting. It actually recommends you to use concat. So append rows after rows, returning new. But what it doesn't say here, it always keep all the columns. So it always perform outer type of concatenation. Instead of giving you an option to specify if you want to do inner or outer, what type of concatenation you want to do. So the preferred method here is to use pandas.concat and put the 3 data objects in here as a list, and then specify index if is 0. But by default, I think it goes by index 0. So that is the default option. And very important to, I think it's join, not type. Join or type. Let's check. So for Python pandas concat, the keyword is join. Outer is the default, so you must overwrite the default behavior of concats and specify join is inner. And once you correctly specify this, you will get a series. Actually, you'll get, maybe not a series, you'll get a data frame with only 1 column there. And then here the code will remove that additional dimension, because 1 column data frame is like a series. So it will squeeze it, will remove 2-dimensional shape and retain only 1 dimension. That becomes a series. Then series has 2 list method, and it becomes a list. You'll get that. Desired output here. All right. So hopefully, for those of you who are not familiar with pandas or don't use pandas.concat a lot, then pandas.concat should become part of your. Actually, have a lot of replies here. Interesting. Looks like you folks will are able to work out a lot of things. But anyway, I'll look at the chat. I was saying pandas.concat should be become one of your useful tools, especially when it comes to vertical concatenation. For margin type of concatenation, for side-by-side SQL style, database SQL style concatenation, better to use merge. Vertically, better to use pd.concat. Horizontally, better to use df.merge, as most of you did in question 13. All right, that's 14. And let me look at the chat here. Any particular question I should pay attention to? Please. Sorry, I was looking at an old thread. Did anybody post anything from the old threads? Now maybe that's why it jumped out. No. Anyway, any questions that I need to pay attention to here? I don't believe so. I don't see any replies. Okay. All right. Question 18. The second part of question 18 is the part of the exam that the most number of students couldn't find a way to work out. So it'll be interesting to talk about how, the strategy that you use to tackle this problem. Anyway, so to do that, we have to first do the first part. You are given a 3x6 data frame with English letters, and you are asked to use apply map function to select the third position letter from each of these words and form a new data frame, and it happens to be Python really superb. This is not very challenging, I would say, because a lot of you are able to do it. So DF18 apply map, and then once you have the apply map, you are supposed to either provide an existing function that can act on each of these English words, such as length. If I do length, you don't need to, and you cannot provide the parentheses. You are only supposed to provide the function name, and it's going to use that, and then to deploy it on, or to enact that on each of the element here. So if I do this, what do I get? I get a data frame 3x6. Each of the element will count the number of characters in each of the words. So the length of each of the words. I get 5, 5, 3, 2, 3, 5. Let's take a look. 5, 5, 3, 2, 3, 5, such and such, right? So this is the most standard way of using apply map. But what if you don't have a existing function, to do what you want to do? You will use the lambda function, right? The anonymous lambda function. It typically goes that, define lambda, use any symbol, and then that symbol becomes takes the role of each of the elements, right? So I extract the letter at the index place 2, and I get an error. Did I do anything wrong? Get the error code. String index out of range. I see. I think I defined it. I was demonstrating the length. I accidentally overwrote the. Well, maybe not. Let's see. DF18. Did I accidentally overwrote the values? No. Okay. Maybe some of you got this error, and this is a good use case to talk about. So, question asked me to get the second letter, not the third. This is the third place. Index position 2 is third. So that's why. If I do it correctly, it will not give me an error. So I guess it's not much more to talk about. Right. So this part is good.
All right, we got that, and then using that, we'll do the second part. The second part asks you to do what? To get three words, and you observe that each of the word is a sort of like a compilation of all the letters, all the elements of each row. So the first thing you need to do is to separate the data frame into 3 rows, or separate out 3 rows. You know, so you would probably think about how to slice each of the row, or how to index each of the row. It's not column wise, it's row wise, right? So here there are, let's see, there are at least 2 ways to kind of do that, but those 2 still are quite similar. If you, the first approach, if you like to do indexing, then let's do that. You know, think about each of the task. We have 3 tasks, kind of. You want to put them together. Each of the tasks is to get each of the rows. So let's get the first row. How do I index the first row? And then so hopefully I can use a for loop or list comprehension to automate that. After the first row, I can do the second row, and then after the second row, I can do the third row. Then you think about a for loop. If I can loop through, how can I loop through the 3 rows? You can use a position index. The first row has position 0, the second row has position 1, so on and so forth. So then the indexing method that comes to my mind is the ilog, right? So df18 ilog will get me 3 rows by changing the index position, right? So if I get this, I get the first row, but in the shape of a series. Actually, if you use my data frame. So I get Python as a series. Now, how do you get from a series to a word? A series to a word. A series to a word. I think we talked about it, right? I just used it. A series to a word, I can use toList. However, they're still separated. How do you put them together? And here you can use something that we talked about in the strings, is the string.join. And this time we use an empty string. By using string.join and join each of the elements of the list, or an array, or a series, whatever, you get a word instead of a list. This is the reverse of making something a list, making a word into a list. The reversing process, right, is to put the list of letters into a single word. And in fact, you don't even have to turn it to list, because with series, you can do the same. So if the first row, you can use this to get the first row, you can certainly get that to get the second row. You don't see the first row because it didn't print anything, so the outcome is skipped, right? And if you can do it on the second row, you can certainly do it on the third row. So you get the 3. The only thing that you need is to put them together, right? Or a slightly dumber way is to get all the 3 and put them into a list. That's more laborsome. That involves more labor. It's more manual, but you can still get the question. To make it automatic, you would retain the format, retain the, I guess, the template, but use a for loop or a list comprehension. For I in range 3, I will rotate from 0 to 1 to 2. As it goes through the 3, it gives me all the 3 words, and then I use a list comprehension to finish off the whole thing. Then I get the output. Is there any other way other than using indexing? Because this sounds more, this looks more, it's not exactly, it's not hard coding for sure, it's list comprehension, it's for loop. But in Python, especially for data analytics, because we have the pandas data objects, a lot of times we can save the for loop. Because a lot for loop is built into a lot of the methods. Being able to use those will make you a more competent data analyst in the Python space. So then we have to talk about the either rows or either items. The two does things in opposite ways. Here we have mydf18, mydf18 dot either rows. What does that do? Either rows will unpack the rows and give you one row at a time. So df.either rows will give you 3 things. And each of the 3 things, because there are 3 rows here, each of the 3 things has 2 things. It's slightly more complex, so takes a little bit time to understand, to get used to. But let's take a look. Data frame that either rows. When you do either rows, it iterates over the rows and gives you, each time gives you a pair. It gives you the index of the row, because here we have metadata. It gives you index of the rows, and then it gives you the content of the series, the values. What we need is not the index. We don't care really about the index values. What we need is the series content. So if we do this, and then we have to again use a for loop to get each of them and to use list comprehension. But this time we don't use the I counter, which is more mechanical. We have 2 things as a couple. We have the label, and we have the series. For each of the pair in the either rows, unpacked rows, and then I only use the series, and then I use the same method. You still have to glue them together, right? So empty string.join, join the content of the series. It's a python, glue them together, get Python. Then for each of the series in the data frame. And then you enclose it into this comprehension, run it, you get the same thing. So, basically 2 ways, 2 efficient ways, 2 elegant ways. They share some similarity. Both of them are list comprehension. You may ask, what is either items? Let's take a look. Instead of either rows, either items will iterate over the columns, and each time also giving you 2 things: the column name and the series, the content of the column, which again is a series. It's more like an array, actually. It gives you the array. Wait a minute. Isn't it? No, it's not. It's actually not an array. It's a series. It has its own indexes coming from the other direction. If you imagine, it's a two-dimensional thing, right? If I modify this to either items, what do I get? I get 6. I get 6 words. I get PRS, YEU, TAP. Such and such, so because it's packing the other one. So obviously this is not what we want. Okay, so that's all I want to review
for the midterm exam in terms of the questions. Any questions? No. Let's see, is there any chance? Did you go over question 13? How do I say your name? Correctly? I know that's not right. Araceli? Araceli? Are you there? Yes, okay. Can you tell me how to pronounce your name? No, I cannot hear you. Maybe you need to adjust your mic. While you do that, so let me take a look at question 13.
Can you hear me now?
Yes, I can.
Oh, sorry about that. Araceli.
Ah, oh, that's tough. Is
No
that Iranian or something close?
Spanish. Spanish.
Spanish. That's why it's hard. Sorry. So question 13 is the merge problem. It's a classic join, you know, kind of SQL-like database style join. Yeah, I can quickly go through that. Let me share that. Okay. Let me know if you cannot see the Jupyter notebook. If I run that, very similarly, the three data frames. So the trick here. So typically when you join, you have two tables. You have A dot merge B, you know, or df1 dot merge df2. How do you merge three? You do it twice. So so that's the deal. So you can do it in one shot or you can do it in two steps. There's df13 dot one merge, and then when you do merge, you cannot put them in a list and merge multiple in one shot. You can do that with pandas.concat, but you can't do that with merge. So that's the deal. So first merge two things, and here specify the merge correctly. And on this part, I don't believe you have no problem. You know, specify the how is the inner, I believe, the inner join. Let's confirm the intersecting merge. Only retain those that are shared. So the how is inner. On is specified the primary key, and I typically also use validate, but it's fine to skip it because most of the time it's fine. So you can either here do it two steps. You assign it to the ultimate data frame name, my df13, and once you have that, you call my df13 merge the second or the third underscore 3, go through the same replication. And don't forget to assign it back to itself. After both of these, and you get what you're supposed to get. Alternatively, you can skip the two-step thing, because once you merge, you get a data frame that's the result of the merge, and then you can continuously call it. And this is a trick I typically use to save me, a few lines and save me a few more typing. You remember me doing a lot of things like checking things, let's say my DF13, I'm checking whether or not it is true. Let's, assume this is it's just an example. Assuming these are, this is the Boolean data frame and it has true and false. I want to check how many trues are there. Like I make a comparison with true using broadcasting, and then I use a parenthesis, and then it becomes a data frame itself. And then I can call the methods of that data frame, So things like that. Always do that. So it's very fine to, to call methods continuously, especially if this is something that you do over and over. You're very familiar with what to expect. I don't recommend this for anything that's new. If you're doing something new, better take it slow, unpack the steps. That also comes handy when you want to debug. It's very easy to get bugs and errors when you are programming something new, right? But here, if it's something that you're very familiar with, you can do it in one shot. Hopefully that helps.
Yes, thank you.
Okay, great. Now, I do see a chat here. Oh, maybe that was you. Okay, great. All right, so that's the exam questions. Let me see. Let me come back to the slides. Pandas that concat. I just showed that. Okay, so time to talk about the teams. Now, for the rest of the semesters, you have a homework 4. That's a teamwork, because that involves some YouTube video uploads. Fun activity. I was like this part of that of the activities get to see you on YouTube. If you haven't made any YouTube videos, you should. I think in this age, you should have a YouTube stream account. For better or for worse. But you also have a hack shop 4. I believe hack shop 4 is an individual work. We'll do that in 3 weeks. In 3 weeks, probably. I think so. When we come back to another face-to-face meeting, that it's virtual meeting, we'll do hack shop 4, and that's an individual work. But then the final project is going to be a teamwork. Each team mostly has 2 members. I have assigned them your teams mostly randomly, but I'll sometimes consider some circumstances. Some students are online, so to make it easier. Some of you are working, I know, so I tend to pair you up with somebody also working. But take a look at the Blackboard. Click the project teams link. You should be able to see your team name and then your team member. And you are able to email, and of course, you can find your teammate on Teams, which is more preferred. I think, establish a link and then, start meeting together for the activities. And you are able to see homework 4 submission item. The teams have been linked to the assignment. You're also able to see the class project, the final project submission item. So, you can feel free to start working on projects, and then let me know if you have any questions. So that is all I plan to say about the teams. Any questions? But once you start working on homework 4 and the teams, I welcome your questions anytime, as well as your TA. All right, I want to say a few things about the modules of focus this week and in the next couple of weeks. Now at this point you are, I would say, your intermediate level of Python, but including maybe there's some rusty points, but given more practices on higher subjects, you're going to be intermediate level by the end of the semester. I would say almost every student gets to that point or above by the end after you go through the project. So now we'll focus more on the more on machine learning concepts, and then try to put Python into use on completing some standard projects, not some projects, but standard projects, problems. And then we'll start with regression as something that you're very familiar with, I would say, linear regression models. We will use stats models as the tool. The package name, stats models. We will conduct hypothesis testing and evaluate the model fit by using a data set and the linear regression model, multiple linear regression model. I want to point out that, although every regression model is the same, the output don't always look the same. The output from R is different from the output from Python stats models. So there's some getting used to. This is a typical, if you go through the steps in the module, then you will get this summary report from a regression analysis, from a regression model that has been trained. It will tell you the model type. It's OLS, ordinary least squares. That's the economic name in economics. The method is least squares. There's no maximum likelihood. It's least squares. There's some technical details. It tells you the basic properties of the data set, and then it tells you a few key statistics. There's an R squared. R squared go from R squared, or sometimes we say R squared. Ranges from 0 to 1, doesn't exceed 1, doesn't fall below 0, 0 and 1. And it's important to know that when you add more variables to a model that's already trained and you get a new R squared is almost always going to increase. No other exceptions, almost always going to increase, but adjusted R squared is not always going to go up because it analyzes having a lot of input variables. Another important statistic to measure model fit, or to measure whether or not the input variables that you include have good predictive power, is the F statistic, overall model fit statistic. And there is a p-value of the model fit statistic, which is the probability of the F statistic, greater than a critical value. This is the p-value. So we use a p-value to interpret and to make conclusions about the model fit. So these are the statistics that you most likely will focus on. I want to mention about the hypothesis testing. When you do hypothesis testing, don't forget about those key steps, especially in the upfront. Even though they kind of are boring because they are not coding, but they are important. When you do hypothesis testing, you want to start with either a research question, what are you testing? A research question or a null hypothesis. What is the status quo? The null hypothesis typically have things that are equal. The null hypothesis said, for example, null hypothesis, NULL, null hypothesis states that the mean of this group, or the mean of this group is equal to 40. That's a null hypothesis. And then you also have an alternative hypothesis or a research hypothesis, which is typically the opposite of the null hypothesis. So state these or understand these first, and then state these clearly before you start to pick an alpha value, typically 0.5, and then pick the test type, which typically is the t-test here, or f-test for the model fit, and then interpret the reports, the statistics, and the p-values, and then make conclusions. Right. So follow the steps that are outlined in the slides. Don't skip, especially the null hypothesis steps. To conduct t-tests on the specific coefficients, as in testing whether or not an input variable is an informative input, you will use a t-test here to test the significance of that input variable. You will look at the coefficient, this is part of the summary report. You will look at the coefficients t-test, and then look at the t-value, and particularly the p-value of getting a t that's bigger than that. And then, you compare that with the alpha value that you selected for the hypothesis testing, and then make your conclusion. Alternatively, you use this is the confidence interval. Use the confidence interval and determine whether or not the confidence interval covers 0. And this confidence interval assumes you choose a alpha value of 0.05. So that's the 2.5 to 97.5 confidence interval. If it crosses 0, then a null hypothesis typically not rejected, fail to reject null hypothesis. But if it does not cross 0, meaning 0 is outside the confidence interval, then you have a high confidence that the statistic is different from 0. And that will be reflected in the p-value as well. So, yeah, so about hypothesis testing, that's mostly it. Beginning module 7, you will deal with key concepts such as overfitting and cross-validation. And in overfitting and cross-validation, there's an important chart that you will be asked to interpret and learn how to read the chart. And the chart is the fitting graph, the fitting chart. And then we typically use a Twain test or Twain validation split sample to examine the fitting chart. The fitting chart will have one line that continuously falls off or climbs, and the other line that will reverse, right? And after you have gone through the materials, you will get to understand that if you keep training a model by increasing the model complexity or increasing the iterations of the training steps on the same data set, the model is going to achieve better and better result on the training sets because it's able to learn more details about the data set. So it's going to perform better. So the line that continuously improves, the line that goes monotonically in one direction, up or down, is the line that represents the training set, while the other is sometimes we call it test set or validation set, or here
the holdout set. So it's fairly, it's logical. Go through the logic several times, make sure you understand the logic, and it's straightforward to identify which line is which. The trick is the fitting graph sometimes plot different quantities on the y-axis, and there are two different kinds. When the y-axis plots the error, which is something that we don't want to be high, then the line, the training set line will continuously go down because it's minimizing the error. Sometimes we draw the graph, but the y-axis represents the performance of the model, which is something we want. The higher the better. Then the line for training set is going to continuously go up because the performance is going up. So be careful on, observing what the y-axis is representing, and then interpret the direction of the lines, and then be able to identify which line represent which set. This is a classic topic in overfitting and cross-validation. So that's all I want to say. I want to highlight in module 6 and 7. As you learn the materials, let me know when you have questions. So some final words about homework 4. I will again, well, maybe I don't have to. Maybe I don't have to share the screen. Homework 4 is fairly straightforward. Homework 4 starts to have more conceptual questions because the topic of overfitting and cross-validation is a heavy one. It's an important one in data science, especially in supervised learning as well as the predictive analytics. So for these conceptual questions, we have equally weights on the conceptual questions and the hands-on questions. So for the hands-on, for the conceptual questions, I'm asking you to use words instead of typing as markdown cells, because you're better versed with words. For homework 4, you'll submit 2 files, the Word file and the Jupyter notebook. Answer all the conceptual questions, including the YouTube link. Put them in the Word and submit it as part of the package. And the other part of the package is the Jupyter notebook, where you will include your hands-on solutions, beginning question 5 in the Jupyter notebook. So be sure to elaborate your question to the conceptual question. Elaborate your answers to the conceptual questions in the Word file. For the hands-on part, it's mostly the content of module 6, I believe. You'll have a simulated data set. You'll analyze a linear regression model, conduct hypothesis testing, and interpret the results in the model fit. Answer a few questions about R-squared and informative inputs. So that's all. That's all. That's all I have planned to talk about. As I said, it's not going to be a long session. It's not short, but it's feasible. Any other questions before we say goodbye? So let's extend the spring break. Let's catch the tail of spring break, if you will. Tonight, if you have party, go there. After this class, you have a couple more hours from the class. But going forward, we're going to have some serious work. All right. Any other questions?
Professor, I wanted to ask, are we gonna get the solution for exam 1?
Solution for exam 1, not exactly because, for one, most of you did excellent. So the solution is going to be the same as what you have. For the few questions that is more challenging or troubling, I just went through. And if I gotta make a solution which only provides one way of doing it, what's the point, right? So for those questions that deserves more attention, I demonstrated several ways to do that. You can rewind the video to revisit those different ways, and that's all. So there really isn't necessary to provide the solution.
Okay, thank you.
Any other questions? All right, let's get to party. I'm kidding, you don't have to. Yay. All right, so you'll learn the materials for almost 3 weeks. We'll come back in the 3rd week from today, right? I'll send a link in the next couple of weeks, just so that you don't get confused about which week to have class. I'll send out the meeting when we get close to, but not so close like today. I'll post it, several days ahead of time. All right. All right, let's call it a night and enjoy the rest of the day.
Thank you.
Thank you, Professor.
Thank you, Professor.
Thank you,
Thank
Professor.
you. Bye-bye.
Great, bye.
Thank you.
Stop the record.